Welcome to The Explainer. Today, we're diving into something pretty ambitious, the Global Institute of Logic and Cybernetics, or GILC for short. It's a project aiming to build a completely new, verifiable foundation for our most critical digital systems.
But to really get what that means, let's start with a really big question. What if our laws, our scientific breakthroughs, even the AI systems we're building, were all based on a foundation that was mathematically provable, ethically consistent, and totally secure for the long term? That's the huge idea we're going to unpack today.
So, why do we even need something like GLC? Well, to understand the solution, you've got to first see the problem. And right now, we're facing a real crisis of digital trust. The foundations we've built on are starting to show some serious cracks.
And this slide just lays it all out, doesn't it? Our institutions are wobbly, with contradictory laws. Our AIs are kind of drifting without any real ethical guardrails. A lot of our science can't even be reproduced. And on top of all that, our entire digital world is vulnerable to future threats. Now, these look like separate issues, but they're not. They all stem from the exact same root problem. We lack a verifiable, logical core for everything.
Okay, so what's the fix? Well, GILC's answer is a blueprint called Digital Fabric Theory, or DFT. You can think of it as the architectural plan for a new kind of digital society, and it all rests on four really powerful pillars. The first pillar is something called fractal scalability, and this is a really cool idea. It basically means that the same fundamental logic that applies to one tiny rule can scale up consistently to govern an entire legal system. It just works no matter how big or small you get, ensuring there are no loopholes or gaps. Next up, you need a shield, right? That's Pillar 2, spectral security. This uses some incredibly advanced math to create a network that is post-quantum secure. In simple terms, it's designed to be safe from the kinds of attacks that the super powerful quantum computers of the future could launch. It's about building security that lasts. Now, this one is absolutely crucial. Pillar 3 is ethical invariance. This lets an organization literally lock in its core ethical principles using math. These rules become invariant, meaning they can't be bent, broken, or contradicted later on, not by a new policy and not by a rogue AI. It's like writing your ethics directly into the system's DNA. And the final pillar, quantum and zeta stabilization. This is a bit heady, but think of it as a way to preserve the logic itself. It uses principles from deep number theory to prevent the system from decaying over time, ensuring that the rules we set today will still be coherent and valid decades or even centuries from now. Okay, so we've got the four pillars. That's the blueprint. But how do you actually build with it? Let's take a look under the hood at the actual machinery that makes all of this work. The first huge shift is getting away from the kind of conventional documents we use now. You know, the ones that are editable, often ambiguous, and full of contradictions. We're moving to what GILC calls a scroll. A scroll is a single, unchangeable unit of knowledge. It's been logically verified, you can trace its entire history, and it's so precise that a machine can understand it perfectly. And here's the thing. Every single scroll has to go through this incredibly rigorous life cycle. It gets drafted, and then the system itself automatically checks it against every other rule to make sure there are no logical or ethical conflicts. Only after it passes that test can a group of human experts, the validators, sign off on it. Then it's sealed cryptographically and stored in a public record forever. It's a totally transparent process from beginning to end. Now, the engine running that whole process is called the kernel stack. Think of it like a stack of filters or a multi-layered shield. Each kernel has one specific job. The signature kernel makes sure you know who wrote what. The ethics kernel enforces those unchangeable rules we talked about. The quantum kernel provides that future-proof security. Together, they create this incredible, multi-dimensional system of trust. So that's the theory and the tech. But this can all feel a little abstract, right? So where does the rubber meet the road? Let's talk about how this actually translates into solving real problems out in the world. The impact is really targeted at the sectors that need long-term trust the most. And you can see it in the breakdown right here. Government is the biggest piece of the pie. That makes sense. Verifiable policy is a huge deal. But right behind it are AI governance, science, and major enterprise systems. These are all the areas that are really feeling the pain from that crisis of trust we talked about. And this chart just connects all the dots perfectly. You've got instability in government. The solution is verifiable policy on public registries. You're worried about AI going off the rails? The answer is ethics-locked enforcement. You have a crisis in science? You get theorems verified by experts. For every major problem, there's a direct structural solution built right into the architecture. So when you boil it all down, this is about so much more than just a new piece of technology. It's about fundamentally rebuilding how our most important institutions work. It's about creating a future that is actually built on verifiable integrity.
And really, the mission statement says it all. The goal is to create an operational substrate, basically a new foundational layer that our institutions can run on top of, a layer that is, by its very design, logical, ethical, and provably true. And look, this isn't just some sci-fi dream for the distant future. As this roadmap shows, there's a real plan in motion. The core infrastructure is being built right now. The plan is to launch the public-facing systems over the next couple of years, with actual pilot programs in government and AI safety right after that. This is happening, step by step.
Which brings us to one last, really powerful question to think about. If we could actually engineer out ambiguity, contradiction, and bad faith from the systems that run our world, what could we build then? What kind of science, what kind of governance, what kind of progress becomes possible when you start with a foundation of absolute trust?